Let's take a look at the questions on homework number 28. First, we'll start with multiplying binomials. Fairly simple. You can either use the box method or double distributing. You'll notice that with each of these directions, they say to express your answer as a trinomial. So they're trying to assist you here with knowing what your answer should look like. So I'm going to use the double distributing method here. I'm going to get 2x squared. That was my first terms. Now my outside terms, right? Sometimes people call this foiling. Then my inside terms, and then my last terms. Typically, your like terms will be in the middle, and when you are done simplifying, you'll get a trinomial. The box method requires you to write a box that has the length of how many terms are in the first binomial, and you write the actual operation as well, and then over here on the side, should match the length of the second polynomial. So if the second polynomial was a trinomial, you'd extend the box like that and you'd make it a bit longer. So for us, we have a binomial times a binomial. Again, we get 2x squared minus 8x plus 3x and minus 12. And this time your like terms will be on the diagonals. So 2x squared minus 5x minus 12. You can use the Shift 6 to get to the power, or you can use this keyboard over here. So we have 2x squared minus 5x minus 12. Okay, I'm going to go to a different topic now, squaring simple binomials. Now with this one, you can expand it out, right? And you could use the box method. You could also use the foiling technique. So here we go. You could expand it out like this, x plus 8 times x plus 8. You could use the box method, x plus 8, x plus 8. You can use a shortcut, which is that you do not distribute the powers, right? But a shortcut would be that we are squaring the first term, we are squaring the last term, and then we are doubling the product of these two. So the product of those two is x times 8, which is 8x, and we need to double that, so we're going to get plus 16x. You'll get the same answer whether you double distribute or whether you use the box method here. See, notice that makes 16x. So x squared plus 16x plus 64. Okay. The next section is arithmetic on polynomial expressions, and that's where you'll be adding or subtracting or maybe some simple distribution. So let's take a look at our question here. We have if c equals this polynomial and d equals that polynomial, find an expression that equals 2 times c plus 3 times d in standard form. So take note, your answer has to be in standard form. So this is the question, 2 times c plus 3 times d, and I'm leaving this obnoxious space because I'm going to erase and replace the letter c with its polynomial, n squared plus 9n minus 8. I'm going to erase and replace the letter d with its polynomial, which is 3n minus 4. I'm going to do some simple distribution here, and then some simple distribution of positive 3 over here. Then we're going to get 2n squared plus 18n minus 16, and then plus 9n minus 12. And I'm going to combine my like terms here and here. And my leading term is n squared, so that should still be first, because in standard form, your highest power comes first. So 18n plus 9n is 27n, and negative 16 and negative 12 make negative 28. 2n squared plus 27n minus 28. Type it in the answer box and click submit. Excellent. The third one will be multiplying polynomials, and sometimes you don't have a binomial times a binomial. So I'm going to take a quick screenshot here and we'll set this up. So again, you have two choices here. You can just distribute multiple times, Or you can set up your box method, which in this case, it would be 2 boxes on the top and 3 boxes along the side for 2x squared minus 3x and minus 3. Or you could go like this, 8x squared, 8x cubed minus 12x squared minus 12x, and now I'm going to move on to distribute the second term. Minus 10x squared, so I'm actually going to write it here, minus 10x squared, because those are like terms, plus 15x, and then plus 15. So I kind of like to add these vertically, and when I'm done, I will have something that is in descending order. Remember, when you add like terms, the exponents of the variables do not change. All right, let's see what we get over here. 4 times 2 is 8x cubed, and then 2 times minus 5 is negative 10x squared. This one will be negative 12x squared. See, we've got our like terms there. And then we've got a positive 15x. And then down here we have negative 12x. There's our diagonals, and plus 15. Then type your answer in and click Submit. Okay, let's take a look at the next topic, difference of perfect squares, also known as dots. And when you factor a difference of two squares, remember you always have one sum and one difference. And when we factor, we square root the first term, we square root the second term. Right? When you square root a variable, you take half of its power. So we're going to write here x, so half of x squared is x, and then the square root of 64 is 8. So x plus 8, x minus 8. Let me try one more in this topic. So again, we know we are going to have a sum and a difference. And this one has a coefficient and a variable, so we're going to get two items here. 4x is our first term, and then the square root of 25 is 5. Okay, let's try factoring trinomials now, also known as your diamond factors, right? Your diamond factors. Now, some of you may notice that your leading coefficient is 1, and every time we slide and then divide, you may realize that dividing by 1 doesn't do anything, so you may choose to leave that off if you'd like. But we always slide a down to c to multiply and get this product, and then we take the b term from the center and we put that positive 8 here. So we're looking of things that multiply to become 15, but things that add or have a sum of 8. And so you can make a list of all your factors of 15, right? You might have 1 and 15, you might have 3 and 5, or 5 and 3. As soon as you repeat, you know you're done. So I'm going to go with 3 and 5. So 3 here and 5 there. It doesn't matter. You can swap the 5 and the 3. Once you go to set up your factors here, you're going to take the square root of this variable, and then you're going to take these factors from over here, and you're going to place them inside. If it's a positive 3 over 1, right, or a positive 5 over 1, and if you can, you should reduce your fractions. If you can't reduce your fraction, that's another topic, then you would move that bottom denominator up. But this is our answer, x plus 3 and x plus 5. So let's type that in real quick, and we'll do another one. So we have x plus 3 and x plus 5. And let's try one more. This time we have x squared minus 6x minus 40. So again, I have my leading coefficient of 1. I'm going to slide down to make a negative 40, slide and divide. If you'd like to, you can erase this since you know dividing by 1 does nothing. And we need a sum of negative 6. All right, the only way to get a product of a negative number is to have one negative and one positive. So I'm starting to think of my factors of 40. And I've got negative 1 and 40 or 1 and negative 40. Okay? And I've got 2 and 20, but that's pretty far away from 6. I've got 5 and 8. What else have we got? Oh, I know. negative 4 and 10, or 4 and negative 10. Alright, so my sum has to be negative. So that means my larger number has to have this sign. So that means the 10 will be negative and the 4 will be positive. So that's how you decide there. You use that, the sign of the sum, to really determine. Alright, so we square root the first term, which is taking half of the power. And then we take these factors over here in any order, and we place them inside. As long as you don't have any fractions here, you're done. If you had a fraction, you'd have to move that bottom number up to become the coefficient. So x minus 10, x plus 4. The order of your binomials does not matter here. You could commute them. You could have x plus 4 first and x minus 10 second. Alright, let's take a look at factoring trinomials when the leading coefficient a is greater than 1. So for this diamond pattern, when you slide down, 5 times 12 is 60, you definitely have to write the divide. Slide, divide, bottoms up. So now I'm going to start thinking about my factors of 60. So, I do that. I should just put my t-chart like this, with the 60 on top. Alright, so I've got 1 and 60, I've got 2 and 30, I've got 3 and 20, I've got 4 and 15. I feel like that's the winner. Yes, 4 and 15 make 19. Very good. 4 and 15 make 19. So now what I'm going to do is I'm going to take a look at my variable. I'm going to take half of its power, and then I'm going to take my answers here. And remember, you cannot have any fractions here. So you have two choices. You can either reduce the fraction, like 15 divided by 5 is 3. And if you can't reduce the fraction, like over here, then you take that bottom denominator and you bring it up to become a coefficient. So 5x plus 4 and x plus 3. You type that in your answer box here. Again, in any order, you can commute these items. So now I'm going to move on because that skill will come up again when we start to solve. But first we have to make sure that we know how to write our quadratics in standard form. So standard form means that all of your terms are on the left side and there's a 0 on the right side. And so in order to do that, I'm going to have to use an inverse operation or add 2x squared to both sides. So if I add 2x squared to this like term, I'm going to get negative 4x squared, and positive 3x remains the same, and positive 13 remains the same. Whoops. Positive 3x, positive 13, and equals 0. Once it equals 0 and your exponents are in descending order, then you are in standard form. Okay, let's try that one more time. This side needs a 0, so I'm going to add x squared. There are no x squareds on the left, so I simply place it in the front because it's the highest degree. So x squared, positive 3x, and minus 4. Don't forget your equals 0. That's a standard form equation. Right? It asks for an equation. Now, once we know how to write standard form equations, we can start solving quadratics by factoring. And there's all different types of factoring, but we're going to start off here with, looks like it's going to be a trinomial. So to solve means you know what the answer for the letter x is, okay? And how many answers you have depends on the highest power. If there are two x's, if there's a power of 2, that means eventually you will have 2 answers for x. So you can't start unless you have an equals 0 on the right side. So we're going to start by subtracting 3 from both sides. And when we do that, we actually get a binomial. So binomials can only be factored using GCF or difference of two squares. This is not a difference of two perfect squares because that variable does not have an even exponent. So it sounds like I'll be using only the GCF. The GCF for these two terms is x, so that's what's going to factor out first. And what remains when I divide each of these by x is x minus 9. Now, anytime you have a product that's equal to 0, either the first factor has to be equal to 0 or the second factor is equal to 0. And that's how we set up our equations for solving. You can't do any solving until you have factored your question into two parts. Right? So for us, it's going to be either x is 0, there's no math to do here, that's done, or adding 9 on both sides here and getting x is equal to 9. So we don't know which one is the answer, but it's either 0 or 9. And you can write them separately like this if it's a show your work question, but in Delta Math they will ask you to list these numbers using braces probably. So 0, 9. Let's take a look. 0, comma, 9. There it goes. See, as soon as I write the comma, it puts those braces in for me to show that there's more than one possible solution. All right, let's try another one. X squared plus 4 equals 5. First, write it in standard form. This has to be a 0 over here, so I'm going to move this 5 over by subtracting 5 from both sides. That gives me x squared minus 1 equals 0. Your only choices for a binomial are GCF or dots. First, always look for a GCF. This doesn't have any. Then you move on to dots. This is a difference of two squares, so this is how I start. Square root of x squared, the square root of 1. Once you have your two factors, you split it into two separate equations. Take these two factors separately, one, then the other. Those are where you get your two equations from. Solve your equations, and there's your two answers, -1 and +1. In Delta Math, you write a comma in between them, and it doesn't matter what order you put them in. Typically, we put them in ascending order, but they'll give it to you no matter which way you try. So each of these questions looks like it's going to be coming down to a GCF or a dots. Let's take a look at this one here. Once I get it in standard form, by moving this 4 over by subtracting it, I'm going to get x squared plus 6x minus 16. Okay, that's a trinomial. That's a diamond pattern. So we slide, divide, and take the middle. So dividing by 1 does nothing, so I'm going to erase this to make less work for myself. And then I start my factors of -16. The only way to have a negative product is to have one negative number. So, well, 1 and 16 is not going to work. So how about 2 and 8, or +2 and -8? I think this will work. Yeah. So -2 and +8 are my factors. And I set them up like this. Square root the first, and then take the factors from the diamond pattern, then split them into two separate equations. The answer here will be 2. The answer here will be -8. So 2 and -8 in any order with a comma in between. 2 and -8. That's how you solve, by factoring. And now we're going to do it all trinomials. So this is all trinomials, no difference of two squares, but that doesn't mean it doesn't have a GCF. So let's take a look at this one. First, let's write it in standard form. So we're going to add 7 to both sides, giving us x squared plus 10x plus 16 equals 0. We're going to slide, divide, and take the middle. Now, dividing by 1 does nothing, so I'm going to erase this to make it less busy. And now I'm thinking about my factor chart. So I've got 1 and 16, 2 and 8, 4 and 4. That's the winner. 2 and 8. Okay, as soon as you have your factors listed, you must show this step. You must show this step where you are proving that this factored sentence here can be split into two different equations, which is why there are two different answers. You don't have to show the inverse operation steps anymore down here, but you have to show that there are two equations. So you can jump right to the answer, oops, -2, and minus 8. So most of you know we're doing minus 2, minus 2, minus 8, and here are our two solutions, minus 2 and minus 8. All right, last one. Let's solve a trinomial with a leading coefficient higher than 1. So this is a challenge, but I think you're up for it. Okay, first, let's get this into standard form. So this one has to disappear. Here's his like term. And this one also has to disappear, and there's its like term. So now our sentence is 3x squared plus 4x minus 4 equals 0, right? You can't start until you have 0 on the right side here. Okay, now I'm going to set up my diamond pattern. I'm going to slide, divide, which I have to do now, and then steal the middle. Okay, I'm looking for factors that make negative 12 and positive 4 as a sum. So we've got 12 and 1, but that's either going to be 13 or 11. And then we've got 2 and 6, so we can either have negative 2, positive 6, or positive 2, negative 6. We could have 3 and 4, negative 3 and 4, 3 and negative. Oh, I think I've got it already because I think these make a positive 4. All right, so negative 2, positive 6. Okay, when you start your factoring here, you square root your variable. And then over here, if you cannot I really don't want you writing a fraction here because we know fractions aren't allowed. So what we really want to start thinking about before we start writing is if it cannot be reduced, right? This cannot be reduced, then we simply write the numerator at the end and we take the bottom and move it up to the front, right? Bottoms up. Slide, divide, bottoms up. Now this one actually can be simplified. 6 divided by 3 is 2, so positive 2 is my only answer there. Now it's time for the last must-be-shown piece of work, and that is that either the first factor is equal to 0 or the second factor is equal to 0. Now how much work you show after this is optional. You can show this work, or you can jump right to knowing that the answer to this is x is equal to negative 2. That's one of the solutions. Now over here, some of you may need to show some work because the answer is going to be a fraction here. And so x is 2/3 and x is negative 2. X is 2/3 and x is negative 2. Do you notice this? The connection to the actual factors we started with, right? The answer is 2/3, but the factor was negative 2/3. The answer is negative 2, but the factor was positive 2. So whatever you have here, right, your answer is always going to be the opposite. So positive 2/3 and negative 2. So we're going to write here our fraction, positive 2/3, comma, negative 2. All right, do you need to say one more? These are kind of hard questions. Okay, one more. Standard form means nothing on the right side. And this one has nothing to combine with over here, so actually this remains the same. The x will change, and the constant didn't have anyone, so there's our new sentence. Slide, negative 12. Divide, and then bottoms up afterwards, maybe. Okay, let's see what we've got here. I need factors of negative 12. That are close together, because they have to have a difference of 1 or a sum of 1. They give 4 and 3, so 4 and negative 3, or negative 4 and 3. This one gives us the sum of negative 1, so negative 4 and 3. Okay, this can be reduced. It won't be an integer, but it can be reduced, so we should reduce it. Negative 2/3. This one can also be reduced. 1/2. Now we will have the right bottoms up, right? You have to reduce it no matter what. You always have to reduce it. So here we go. Our two factors are, whoops, let me leave a little space here. Negative 2/3, negative 2/3, that's messy. Negative 2/3 and positive 1/2. Remember, no fractions in your factors, so take this bottom and move it up. Take this bottom and move it up. So it's 3x minus 2 is equal to 0, or 2x plus 1 is equal to 0. Now you've got some solving to do. X is either negative 1/2, which again, opposite sign of our factor, and 3x equals 2/3, which again, opposite sign of our factor, so we know we did it right. So our answers are positive 2/3 and negative 1/2. Positive 2/3 and negative 1/2. All right. Good luck with your homework.